Hello, good morning to everyone. This is Xavier Banquet, CEO at Rokubun. Welcome everyone to this OSNMA SDK webinar. I hope you'll enjoy this. Um, so, needless to say, you can leave your comments out there, and I'll try my best to respond your questions by the very end. And otherwise, you can always reach us out at info@rokubun.com. So, um, let's um, let's start. Um, so we're gonna talk about empowering your navigation device with authentication against interference today. It's gonna be a short 30-minute event with two separated parts. Within the first part, we're gonna have a very quick introduction to what Galileo OSNMA is. And within the second part, we're going to talk about Rokubun's solution concerning the OSNMA, which is the solution you can be using to empower your navigation device with authenticated navigation. So, Galileo OSNMA. This is the pioneer GNSS service for authentication. Little bit of introduction for those not very acquainted with what GNSS is. As you may or may not know, GNSS stands for Global Navigation Satellite Systems. In a nutshell, this is a set of medium Earth orbit constellation of satellites for navigation applications that do provide autonomous geospatial location, geospatial positioning. Okay, those solutions are or can be coarsely divided within three domains, which is the space segment, the ground segment, and the user segment. Today, we're going to be mostly concentrated on the user segment. GNSS offers a global coverage, which means that you can use GNSS to locate your device wherever in the planet. And normally, as a kind of a rule of thumb, the receiver outdoor position estimates do lie within an error of more or less few meters. Okay, and GNSS is everywhere. I mean, according to the European Commission, more or less 7% of the European Union GDP gross product is dependent on the availability of GNSS satellite solutions. So it's everywhere. It's in immediate of applications today. It's not anymore a geek space technology, but a commodity. So how comes that we do care about robustness in GNSS? So the interference challenge. So in recent years, we've been experiencing that GNSS solutions are not very, say, robust to some kind of interferences. And we're talking especially here about spoofing. Spoofing, it's a kind of interference that is based on falsifying the signal of the satellite navigation so that we are faking the position estimation that GNSS receivers do compute. So that's a very painful menace threat, because normally GNSS receivers do not detect, as opposed to other interference like jamming that totally blocks GNSS receiver to provide a solution. Spoofing hacks the solution without the receiver being aware that it's being hacked. Today, you can buy by a few hundreds of dollars the hardware equipment you need to generate a spoofer. So it's a real threat. A proof that it's a real threat, it's just a few examples of some spoofing events registered in the past and present in the media. It is especially relevant. The news in Inside GNSS entitled "From Russia with Love for Christmas: Jamming Baltic GPS." That's from last week, right? So it's happening today. I mean, it's everywhere. Spoofing and jamming GNSS events are happening more and more, albeit not always they are published, they are registered. Sometimes because authorities don't want to admit it, sometimes because they don't even realize they've been spoofed. Okay, so out of this robustness necessity of the GNSS solutions, the Galileo, which, as you know, it's the European GNSS constellation, is about to introduce a pioneering innovative service, which is called OSNMA, that stands for Open Service Navigation Message Authentication, that ultimately aims at detecting spoofing, right? So the first thing you need to do is to detect spoofing in order to flag with a red flag, alert your GNSS user that the GNSS solution cannot be trusted anymore, right? Mm, in the left-hand side of this slide, you have the high-level architecture of what the OSNMA looks like. So the OSNMA, the navigation message authentication service, it's something that comes from the ground segment, and it's broadcasted through the space segment, through the signal in space. So satellites do broadcast this service, so that a GNSS receiver which is equipped with a specific firmware software necessary for the reception and the processing of OSNMA can be OSNMA enabled, which means that it's not only going to provide a GNSS location estimation, but as well an authentication status of the navigation message of this GNSS solution, as a measure that your solution it's not being spoofed, right? This OSNMA is based on a broadcast lightweight authentication protocol, which is called Tesla, which is a cryptographic real-time algorithm. So when talking about OSNMA, let's be a little bit geek now. Just a few details. I'm not gonna get in deep, but at least few details. So there's two main parts on the OSNMA: the reception and the processing, or the reception and the authentication. OSNMA service is transmitted via the Galileo navigation message, the INAP, in the E1B signal. It's transmitted on a subframe basis, so you need to receive the navigation message on a subframe basis, which is ultimately what it's going to be authenticated. As you know, or you may not know, this navigation data is essential to compute the GNSS receiver location estimation. And then within this navigation message, there's a specific field in the navigation pages for the OSNMA that transmits, on the one hand, the Tesla root key, and on the other hand, the message authentication codes and the key, which are the data, the tags, and the chain key to verify those tags. Then what about OSNMA authentication? In a very summarized picture, the OSNMA consists in the following procedure. So first of all, the receiver gets the navigation data plus the OSNMA data, which is the tag, the chain key, and the root key. All these data, both navigation data and OSNMA data, is parsed from the E1B signal in space. Then once this data has been properly received and it's within our receiver, within our GNSS receiver, first thing that has to be done is to authenticate the Tesla root key by using a public key, which is provided by Galileo authorities. In that case, it's provided by the Galileo Service Center. Then once you have the root key authenticated, you use this root key to authenticate the chain key, which is used subsequently together with the navigation data to regenerate the tag. And this regenerated tag in the receiver, it's compared with the received tag as the measure, as the means of checking authentication. So should the regenerated tag and the received tag coincide, it means that OSNMA is authenticated. Then, what about use cases? So why is it, where OSNMA is going to be relevant? So OSNMA is going to be relevant for all those use cases relying on navigation that are in need of secure and robust navigation. So essentially, in which navigation information is liable for something, such as, for example, demand responsive transport or micromobility, which, by the way, this is a topic which is going to be touched by Horizon Europe European Commission project in which Rokubun is involved, named Julia. This project aims at exploring the benefits of the Galileo navigation differentiators in public transport. So other potential applications are those related with the road telematics, such as insurance telematics or road user charging, because obviously the navigation information is going to be liable to generate the invoice to the customer's driving. Obviously, autonomous vehicles, right? Autonomous vehicles do need to know whether they can trust or not the GNSS estimation in order to use it or not within the autopilot information. And drone surveillance, right? In drone surveillance, drone operators need to know whether the images or the videos they are acquiring are indeed in the zone they expect it to be, right? So GNSS location estimations can be liable for further applications, such as, I don't know, illegal fishery activities detection, this kind of stuff. Then let's jump into the second part of this webinar. So what's been done at Rokubun concerning this Galileo open service navigation message authentication? So what has been done, it's the Rokubun's OSNMA SDK software development kit, right? This is an embedded software library to enable the use of Galileo OSNMA authentication in your navigation devices. So essentially, you can license this library to provide authenticated navigation in your navigation solution, right? This is a picture which was published at the GPS Wall website, featuring our OSNMA SDK library. So let's be very clear from the very beginning. So Rokubun's OSNMA SDK is for you if you are a GNSS chipset manufacturer. So GNSS chipset, namely system and chip, system and module, system and package. So should you be providing GNSS solutions at chipset level or at module level, that can be interesting for you to enable your solution in using authenticated navigation based on Galileo OSNMA. In case you are a GNSS receiver manufacturer, right? So you are ultimately providing a GNSS receiver solution, and you wanna give your customers the added value of authenticated navigation in your GNSS receiver by using the OSNMA SDK. You are a navigation solutions integrator, so an electronics integrator, namely an automotive tier 1 or a robotics or drone navigation onboard unit manufacturer. And you want your navigation unit able to provide authenticated navigation so that your customers can have an additional trust on the authenticity, on the genuinity of your navigation solution. And finally, it may be as well relevant for GNSS simulators and scientific receivers, especially for validation purposes. So that said, let's have a look at what Rokubun's OSNMA SDK is doing, right? So essentially, as I said, this is an SDK. This is a software library that goes embedded within the microcontroller unit of your navigation solution. It runs in parallel with the normal GNSS processing activities of your GNSS receiver. And what this library is doing is essentially a two-step process, as I've been introducing in the first part of the webinar. First of all, it fetches all the needed data from the navigation message, right? So it fetches the specific pages in the E1B signal so that it is able to retrieve the navigation data and the OSNMA batch of data. And this goes into the OSNMA processor, which is the authentication step, to finally deliver an output, which is the OSNMA status report, which can be delivered every 30 seconds, which is the subframe rate of arrival. This output might be OSNMA authentication success for those Galileo satellites that have been properly authenticated with the OSNMA, OSNMA authentication error, which should raise an alarm flag on your device, and finally, no OSNMA data available. So let's see a short animation of what this would look like in a standard receiver. So the output, it's the authentication of the satellites. On the real life, what you see is that Galileo satellites are more and more authenticated. Your receiver starts without having any Galileo satellite authentication, but as time goes by, you see that the Galileo satellites are properly authenticated so that you can trust those navigation solutions provided by those satellites. So we are authenticating. Well, that's not we. That's what it is established in the interface control document. We are authenticating three types of data: the ADKD0, which is the ephemeris and clock and status data, and the ADKD4, which is the timing parameters needed to translate from one GNSS scale to another one. And finally, the ADKD12, which is kind of very similar to ADKD0, but with a certain delay, 10 subframes delay, more specifically. So what has been the journey covered by Rokubun in order to publish, in order to release this OSNMA SDK commercial library? So we've been facing two problems, and our final solution is the result of overcoming those two challenges. On the one hand, embedded, and on the other hand, suboptimal reception conditions, right? So it is very easy, and you'll find out there open source libraries for OSNMA, right? Because using a MATLAB script or a Python script to implement what the OSNMA interface control document establishes in a vanilla or in a nominal implementation, it's not that difficult, right? But once you go to the embedded world, which has certainly very strict limitations and constraints in memory footprint and computational power, things do not get as easy as at the very beginning, right? So what we did was we started with a vanilla implementation, and then we moved this implementation to a brand new one, which was targeting specially embedded devices, right? This embedded initial version of the OSNMA SDK successfully completed a validation set of tests in the European Commission Joint Research Center Galileo testing facilities in Ispra, Italy, by using the specific simulated spoofing and non-spoofing scenarios. And then once we had this embedded oriented version, which means very small and very small footprint and very small computational power needs, we faced a second challenge, which is the suboptimal reception conditions, right? We did an example of a bike ride within a urban scenario, and our findings were that in terms of subframe quality, which measures the percentage of received subframes with respect to the expected ones, given a time period of a spanned time period, this quality is very low. In urban environments, it can be as low as a 23%, 20%, and in normal or in optimal urban scenario conditions, it ranges around 50%. What does it mean? This means essentially that out of the 100% of data that you should be receiving for a proper usage of the OSNMA algorithms, in urban conditions, you'll be normally receiving less than 50% of this data, which means that the OSNMA SDK at Rokubun had to be made robust enough to be working in non-continuous data reception. Okay, this is something. This feature of being an OSNMA algorithm robust to work in suboptimal reception conditions, that's something that's going to be proven within the Julia project I mentioned before, because this is going to include pilots pilots with public transport operators in urban environment. So All in all, after solving those big challenges, our OSNMA SDK has the following unique selling points, so the following differentiators. First, it is a perfect fit for embedded and automotive, since the library has been engineered from the very beginning with a very low language level, specifically in C, and it's MISRA compliant, so it does not have any deep external dependencies. It does not uses dynamic memory. So it has a small footprint, big advantages, right? So the library, the version 1, version 2, which is about to be released, it might be even better, but version 1 was just 60 kilobytes of code from the needs of flash memory, and it was using only 15 kilobytes of RAM, which makes it suitable for embedded like microcontroller units such as, I don't know, ARM, Cortex M4, and this kind of family of microcontrollers, which is normally the one present in GNSS embedded solutions. It is cross-platform, which means that you can expect easy integration in your device, in your navigation device. So the library has been designed to be architecture and operative system agnostic, allowing for smooth integration in each and every platform. And it is robust to suboptimal reception conditions, right? Because otherwise, this is a solution that would not work in urban environments, and urban environments are principal scenarios in GNSS solutions. So our library is able to provide Galileo OSNMA authentication anywhere. And that's kind of it, right? So concerning development roadmap, as I said, more or less, so we started roughly 1 year ago with the release of the first beta version by March 2023. Then we published in September 2023 the first version, the embedded suitable one. And we're about to publish the embedded version 2, which is the one robust to working in urban environments by end of February or beginning of March this year. So stay tuned. Finally, some credits. Most of the materials I've been using in this presentation do come from either the ESA Navipedia, which is a kind of a Wikipedia about GNSS navigation, and obviously from the official Galileo OSNMA documents provided by the European Union Space Program Agency, EUSPA, in Prague. And that's all from my side. So thanks so much for your attention. And please bear in mind that should you want more information, or should you want to have access to the slides using in this presentation, just drop us an email at info@rokubun.cat for more information. I see no specific comments, no questions. So I guess that either I was very boring, or I've been clear enough. So I'm gonna say bye, and I hope to be in touch with you, especially with those interested. So bye bye.